Different portions picked out of different powers of 10 can be added together. Let's say, for instance, some portions are picked out of 10, other portions picked out of 100, others picked out of 1,000, in that manner, and they are all joined together. When they are joined together in summation, usually we summarize that summation in a form that is simpler. When we see numbers, fractions, decimal fractions written in their dot notation forms, that is exactly the message that number is passing, that decimal fraction is passing. Every decimal fraction tells us that each digit in that decimal fraction is picked out of a specified power of 10. Let's say, for instance, 0.378. 378 exists after the dot in that notation. From what power of 10 is that 3 picked? From what power of 10 is the 7 picked? From what power of 10 is the 8 picked? That takes us to the fifth lesson objective of this presentation. And what is it? Decimal places and place values. Please join me as I explain this concept of decimal places and place values. In this section, we'll learn decimal places and place values. What is a decimal place? What is a place value? Let us start learning about decimal places. Afterwards, we'll learn about place values. Permit me to use this 1/8 to explain decimal places. 1/8 is a fraction in its vulgar form. It is obvious. I want to convert this vulgar form of fraction, 1/8, to a decimal form of fraction in its dot notation. Please follow me as I convert 1/8 to decimal in dot form. To enable us convert this 1/8 to a decimal form, we should see this 1/8 as a division. That is 1/8. We know that primarily it means 1 taken out of 8. But it also means 8 dividing 1. If 1 orange is brought and 8 persons are to divide 8, this is also how to write that. That is 8 persons to divide 1 whole orange. Don't forget that originally it meant 1 taken out of 8 portions. That concept was used before and will be used again. But for us to get to understand the concept of decimal places, we shall see, and we keep on seeing 1/8 as division until the end of 8. So right now, configure your minds to accept 1/8 as 8 dividing 1. That is, 8 persons are given 1 orange to divide or to share among themselves. And while they share this orange, they must bear it in mind that everybody will get an equal share. The next thing is, what do they do? Will they just break this orange into 8 and take it 1 each? That is possible. But don't forget what I told you earlier about history of development of fractions and different forms of fractions. Don't forget that at a point in history, people began to choose to divide something into 10 and powers of 10 and choose from them. It is that idea we're going to bring in as we convert this 1/8 to decimal form in dot formation. Okay, now, when 8 persons are to divide 1 orange, Following that idea of breaking something into 10 or parts of 10 before sharing, do you think that this 1 should be broken into 10, 100, or 1,000, or 1 million? Anyway, any of them will serve, but it is noteworthy that it is the best to choose a part of 10 nearest to this 8 to break this 1 orange into. The nearest part of 10 to 8 is 10. Therefore, we're going to divide this 1 orange into 10. But before then, let me write something here as a part of the final result that shows that nobody got 1 whole orange. What do you think I should write to show that none of these 8 persons got 1 whole orange, that everything they will get later will only be portions of 1 orange? Please see it. And here it comes. It is 0 point. This 0 tells us that there is no whole number. When 8 persons divide 1 orange, you wouldn't expect anyone to get 1 full orange. So it is 0 full orange that 8 person got. So this dot here is showing that whatever follows after 8 is no longer a whole orange, but portions of orange. So dot signals occurrence of fractions or portions. Let's make progress. Now back to what I was saying earlier. Which part of 10 should these 8 persons divide this 1 orange to? It is not 100, it is 10, because the nearest part of 10 to 8 is 10. Now, let me write this 1 as 10 below here. And this is it. This 10 simply shows how many portions they have broken this 1 orange into. So this 1 orange has been broken into 10 portions. It is now time for 8 persons to pick from this 10. If 8 persons pick from this 10, how many will each person pick? 1 person will pick at least 1 portion. Let me write 1 portion here as the share each person will get when 8 persons pick from 10 portions. That means 1 should be here. Let me write it. That is it. 1. That means every person among these 8 persons got 1 portion from this 10. After each person took 1 portion from those 10 portions, how many portions are remaining? To know how many portions are remaining, let us take this 8 out of the 10 and check how many portions remaining. Watch me as I do it. Yes, if you take 8 out of these 10, 2 portions will remain. These 2 portions can no longer go to these 8 persons. Something will happen again. These 2 portions, please, who owns them? It is still these 8 persons that own these 2 portions. And the 8 persons must again break these 2 into more portions and pick from them. To understand how they should break these 2 into more portions, let us recall that these 2 means 1 portion plus 1 portion. Let me write it. And here it comes. These 2 portions simply mean 1 portion and 1 portion. That means 1 portion and another portion remained after 8 persons picked from 10. Now, something should happen to this portion, and something should happen to this portion too. What happens again? This 1 small portion will again be broken into another 10. The same thing happens here. So let me break this 1 into 10 portions, and this 1 also into 10 portions as usual. Let me do the division. Bearing in mind that the division takes place in our mind, please find out what this will turn out to be after I have divided 1 into 10 and the second one into 10. Please watch out. And here it comes. This 1 broken into 10, see it here. This one other portion broken into 10, see it here. That means altogether, they now have 20 smaller portions from which 8 persons will pick. Please, when 8 persons pick from these 20, how many portions will each person get? What is the number nearest to 20 that this 8 can divide without remainder? Is it 8? Is it 12? Is it 16? Is it 20 itself? No. The answer is 16. The number nearest to 20 that these 8 persons can pick from and pick whole number of portions from without remainder is 16. That means that 8 persons will pick from 16. When they pick from 16, how many portions will each person get? Each person will get 2 portions. Now that we have written this, we have seen these 2 written, meaning how many portions each person got from these 2, from the 16. The next thing should be, after these 8 persons have picked from 16, meanwhile it was 20 portions they picked from. Please, how many portions have not been picked? To get how many portions that haven't been picked, we subtract that 16, which they picked from these 20. And after that, we know what is remaining. Let that happen. And here it comes. 20 minus 16 portions will give us 4 portions. That means there are still 4 portions remaining unpicked. How many persons? Who owns these 4 portions? The same 8 persons are to divide these 4 portions. That means these 4 portions still belong to the 8 persons. You can imagine the size of each of these 4 portions. To get to know more about these 4, let me write these 4 as units. I want to write these 4 not just as 4, but as sum of units. That is, certain numbers add up to 4, and those numbers each are 1. Let me write 4 as 1 plus 1 plus 1 plus 1. Please watch. And here it comes. This 4 is the same thing as 1 portion plus 1 portion plus 1 portion plus 1 portion. What happens next? Each of these 4 portions will again be broken into how many? 10. Break this into 10 and let the 8 persons share. Break this into 10 again. The same thing will happen. This into 10 and this into 10. Please, let us mentally divide this 1, this 1, this 1, this 1, each into 10. Let it happen. Yes, these are the 10s into which each one has been divided. This 1 broken into 10, this 1 into 10, this 1 into 10, this 1 into 10. Then all together, we now have 40 portions from which these 8 persons will still share. Now, when 8 persons start sharing 40 portions, will there be a remainder? Certainly no. Okay, when 8 persons share from these 40, what share will each person get? That takes us to 40 divided by 8. What will it be? The answer is 5. That means when 8 persons share 40, each person will get 5 shares. That means 5 written here. Let me write that. And here it comes. 5 is now here to show how many portions each person got from these 40 portions. I ask again, will there be a remainder after 8 persons have shared from the 40 portions? The answer remains no. That means that this is the end of the process of converting this vulgar fraction to this decimal form in dot notation. If there is still a remainder at this stage, then the entire process or procedure will be repeated until, if possible, they get tired of dividing or they divide without remainder. But already we have seen that after 3 rounds of divisions and picking from those portions, the entire process came to an end. Therefore, we can summarize that 1/8, which is a vulgar fraction when converted into decimal in dot form, will be expressed as 0.125. Therefore, this and this are the same, but expressed in different forms. Now, believing that we remember what happened from here to this point, let us now concentrate on 1/8 is equal to 0.125. Now, concentrating on the results of that process, we then conclude that in 0.125, that is this 0.125, there are 3 decimal places. What does this statement mean? Let's find out. Now see the meaning. This statement means that 3 rounds of sharing produced this 0.125. I hope you agree with me. Recall what happened when I was converting 1/8 to 0.125. How many times did the 8 persons have to pick from portions? Let's recall. This first one was broken into 10, and they picked from the 10. Each person got to 1 portion. 2 remained, and each of the 2 was broken into 10 each, and 20 portions resulted. When 8 persons began to pick, again they picked from 20 portions. They picked 16 out of 20. And that is second round of picking. Each person got 2 portions. So this 2 refers to the result of second round of picking. And as a result, 4 portions remained unpicked. Each of those 4 portions was again broken into 10. And when put together, 40 portions were available for picking. The third time, 8 persons had to pick from 40, and each person got 5 portions, and the picking and the division stopped because there was no more remainder. In all, there were 3 times the 8 persons had to pick from portions. Because of that, we say that there are 3 decimal places in this. This means that 3 rounds of sharing took place before 0.125 was produced. That is the meaning of this statement. So far, what will you say is the definition of decimal places, having seen the way all these things turned out to be? What are you thinking? Please, wait a while. While you are thinking, just wait. I'll also give you a definition and you compare my definition with what you are thinking. Please, find the definition of decimal places on the screen. And here comes the definition of decimal place. It says, decimal place is the number of rounds of sharing when more divisors share less dividend. Does that make sense to you? Number of rounds, that is number of times. Here, sharing occurred 3 times. What it means is that it has 3 decimal places. That is 0.125 has 3 decimal places. In this process of division, which one is the dividend and which one is the divisor? The dividend is that being divided. It is this one that is called the dividend. then the 8 persons dividing it may be called the divisors. I did not use persons here. I just used divisors. Why? Because it is never compulsory that when something is being shared, that it must be persons sharing that thing. Some other things can share anything. The name for whatever shares or divides anything is divisor. Therefore, this word divisor is more appropriate when compared to the word persons. Again, decimal place is number of rounds of sharing when more divisors share less dividend. Now, let us see more examples of decimal fractions in dot notation with respect to the number of decimal places in them. Please watch out. Now, find more examples. In 0.2, there is only one decimal place. That is 1 dp. Why? It is only one round of sharing that produced 0.2. From whatever vulgar fraction that 0.2 came, this 0.2 only tells us that only one round of sharing took place and 0.2 was produced. Next, in 0.05, there are 2 decimal places or 2 dp. What this also means is that from whichever vulgar fraction that this 0.05 was produced, there were 2 rounds of sharing that produced this 0.05. This example highlights the importance of the fact that even 0 is a part of decimal places. In time, we'll find out how possible it is to make 0 a part of decimal places. Until then, just know that here, because 0 occurs after this dot, it is also part of the number of times sharing took place. Let's make progress. The third one says, in 0.137, there are 3 decimal places or 3 dp. What it means is that from whichever vulgar fraction 0.137 came, 3 rounds of sharing took place before it was produced. What about the last one, 0.3558? Can you tell? Certainly, there are 4 decimal places, that is 4 dp in it. What that means is that from whichever vulgar fraction that this 0.3558 came, there we have 4 rounds of sharing to produce 8. We can have many more examples. We can have 5 decimal places, 6 decimal places. Just count how many digits after a dot. That tells you the number of decimal places. So the shortcut is just count after the dot towards the right how many digits we have there. Because here we have 1 digit, it has 1 decimal place, 2 digits, 2 decimal places, 3 digits here. We then have 3 decimal places, and here we have 4 digits corresponding to 4 decimal places. Now, look out for an exercise. And here comes the checkpoint. It says, determine the number of decimal places in each of the following decimal fractions. 1, 0.8, 2, 0.118, 3, 0.20, 4, 0.9115, 5, 0.007, and 6, 0.0112. At this point, we pay attention to place value. We just finished talking about decimal places, and I hope that everything said therein was clear. Now, what about place values? What really is a place value? Before we get to understand the meaning of place values, let us learn to interpret and analyze dot notations of decimal fractions. Let us first learn to interpret. To start with, what do you think this 0.1 means? Recall, if you can, just what is the meaning of this 0.1? Let me remind you. And that's the reminder. 0.1 means 1 picked out of 10 portions. Let us in like manner see other ways, other decimal fractions written in dot forms or notations are interpreted. Please watch out. And here come on the examples. The second example is here. 0.01 means 1 picked out of 100 portions. 0.055 means 55 picked out of 1,000 portions. The next, that is number 4. 0.152 means 152 picked out of 1,000 portions. Later in this same subsection, you'll be tested as to whether you understood these interpretations. Next is for us to analyze this form of dot notation of decimal fractions. Please watch out as I pick one example of a decimal fraction in each dot notation to analyze dot notations. Please watch out. Now find an example of a decimal fraction with which I want to exemplify analysis of such form of a fraction. It is 0.2156. Many persons may not have known before now that this 0.2156, for instance, is outlined like this, that certain decimal fractions, when added together, will give us this 0.2156. The question is, what are those individual decimal fractions in their dot notations which, when added, will produce 0.2156? It is the process of separating this into those individual decimal fractions, which, when added, will produce this that we call analysis of this decimal fraction. Now, again, find on the right-hand side where this 0.215 has been analyzed. Obviously, 0.2156 means the same thing as 0.0006 plus 0.005 plus 0.01 plus 0.2. Please pause for a while and be sure that you know how this came to be this when outlined and analyzed. To be sure that we are getting it right, please let us add up these decimal fractions so that we check the answer which we want to write in this space, and afterwards we compare the answer with this 0.2156. Let us add, please. We have learned earlier how to add such individual decimal fractions, and believing that has been done by you, let us add, please. This 6, bring it down, it will be here. 0 plus 5 is 5. 0 plus 0 plus 1 is 1. 0 plus 0 plus 0 plus 2 is 2. Then bring down the dot here and then add up all the zeros. What then will be here? Let me write the answer. And that is it. 0.2156. This is brought down here. 0.5. 0 plus 5, please, is 5. 0 plus 0 plus 1, 1. 0 plus 0 plus 0 plus 2, 2. Then the dot here, and then zeros added is the same 0. Please compare this with this. Something is clear. The two of them are the same. Therefore, this when analyzed in this way, will give us the same answer. So this whole process only serves one purpose. The purpose is to tell us that every decimal fraction is composed of different decimal fractions added together. Now back to my question. What is place value? Let us learn to define place value using this 0.2156. Notice that here we want to know from what part of 10 this 6 was picked. Look at it here. This 0.0006. Then the way it appears here suggests that 6 was picked out of a particular part of 10. What part of 10 is that from which 6 was picked? Keep on thinking about it as we take the next digit. Again, we ask, what about this 5? From which part of 10 was this 5 picked? With respect to how it is shown here, we have 0.005. With the way it is shown, what is that part of 10 from which this 5 was picked? Again, keep on thinking. We shall get back to it. What about this 1? From which part of 10 was this 1 picked? From the way it is analyzed here as 0.01, we ask, from which part of 10 was the 1 picked? Again, later we get back to it and answer it. Then now, what about these 2? From which part of 10 was it picked? Look at its own analysis. Now, back to this place. And with this, we can answer our questions, our foregoing questions. Now, with the way this 0.0006 is written, and with what we have learned before, just a short while ago, about interpreting decimal fractions in dot notation, we can conclude that this 6 was picked out of how many? Out of 10,000. 6 was picked out of 10,000. Just watch it. How many digits do you have from this point towards the right? It is 1, 2, 3, 4. That means there are 4 zeros in the part of 10 from which 6 was picked. Which part of 10 has 4 zeros? It is 10,000. Therefore, 6 was picked out of 10,000. Please take note of that. What about this one? 0.005. From this dot, or after the dot, we have 1, 2, 3 digits. This will help us to know from which part of 10 5 was picked. Which part of 10 has 3 zeros corresponding to 3 digits? It is 1,000. Therefore, 5 was picked. This 5 was picked out of 1,000, and this 6 was picked out of 10,000. I hope you are following what I'm saying here. Now let's continue. What about this 1? From the way it is written here, we have 2 digits corresponding to 2 zeros in the part of 10 from which that 1 was picked. Which part of 10 has 2 zeros in it? It is 100. Therefore, 1 was picked out of 100. Now, the last one is 2. From which part of 10 was the 2 picked? From the way it is written here, the 2 were picked from 10. Why? We have only 1 digit here, corresponding to only 1 zero from the part of 10 it was picked from. Because of that, we say 6 picked out of 10,000, 5 picked out of 1,000, this 1 picked out of 100, and this 2 picked out of 10. With this analysis, we can now answer the question, what is that? We asked, what is the place value of 2? What is the place value of 1? What is the place value of 5? What is the place value of 6 in this decimal fraction? Please watch out as I write the answers. And here you have them. Number 1, place value of 6 is 10,000. Place value of 5 is 1,000. Place value of 1 is 100. Place value of 2 is 1/10. At this point, what then do you think is the definition of place values? Before then, I just hope that you have understood so far all I've said respecting place values. Now, back to it. What will you say is the definition of place values? As you are thinking, let me write the definition on the screen. And after that, you compare what you have seen on the screen with what you are thinking. Please find the definition of place value. Okay, based on what we have seen so far, this is possibly one of the ways we can define place value of a digit. So place value of a digit in a decimal fraction is the power of 10 from which the digit is believed to have been picked. I hope that this definition explains itself in view of the foregoing. And here are the more examples. In 0.895, the place value of 5, that is this 5, is equal to 1,000. I hope you agree. And the place value of 9, that is this 9, is 100. And the place value of 8, that is this 8, is 1/10. I hope that is clear to you. Now, the next example is this. In 0.3462, it has 4 decimal places, you know. Each of these digits has its decimal place or place value. 1. The place value of 2, that is this 2, is 10,000. I hope you agree also. Then next, the place value of 6, that is this 6 here, is 1,000. And the place value of 4, that is this 4, is 100. And then the place value of this 3 is 1/10. Now, watch out for an exercise. Check if you understood all I have said in place values by answering the following questions. Please watch out. And here comes the checkpoint. The first question says, analyze, then interpret each of the following decimal fractions. A, 0.1158. B, 0.33591. C, 0.811355. D, 0.76751. Number 2 question says, determine the place value of each digit in the decimal fractions that follow. I just hope you understand this instruction. Hoping you have done that, let me read the decimal fractions. Number A, 0.3551. Number B, 0.115. Number C, 0.19885. Number D, 0.6258.